In this example, we are looking to find a volume given by some bounds, and we're going to leave our final answer in terms of pi. So here's what we got going on. We are trying to find the exact volume of a solid as a multiple of pi, so it just means in terms of pi, obtained by rotating a region bounded by quadratic, and then this point, y equals 0, and we are rotating it around the x-axis. So let's draw a picture, give us a little bit of a visual of what we got going on. So we're going to be bounded by 1 and y equals 0, right? So y equaling 0 is essentially the x-axis, and we're going to go out 1. And if I plug 1 into this equation, I get 6. 1, 2, 3, 4, 5, 6. So we have a quadratic that's bounded with this. So this is our area that we're going to rotate it around the x-axis. So it'll kind of contain some sort of a disc-looking thing. So how do we go about figuring out its volume? So remember that you're creating these discs, these cylinders, and the formula for finding the area of a cylinder is area of the base times the height. So for calc, that means that shifts us into doing an integral of pi. Our radius is constantly changing and it's dictated on an equation. So some sort of an equation squared. And then our height is our thickness of all of these cylinders, and they become infinitely small, thus the integral. And so it's going to be dx. So our trick basically is we need to figure out what our bounds are and what is it our equation is that we're squaring, and then we'll do the math. So this is going from 0 to 1, and we're going to be rotating this around. So 0 to 1, pi r squared is this equation. So 6x squared squared dx. All right, so not bad. Let's see what this turns into. I'm going to take this pi out. I'm going to simplify this before we do our integral. This is going to be a 36x to the fourth once I square it. 36x to the fourth. And then we'll do our antiderivative. So we'll leave the pi out. Antiderivative of this is going to be 36x to the fifth divided by 5. And we're going to go from 0 to 1. All right, so let's plug some values in. Still got that pi. It's going to eventually float into the answer. But we're going to take 36 times 1 to the fifth. 1 to the fifth over 5 minus 0 being plugged in, which is just 0. So we're looking at 36 to the fifth. So pi times 36 fifths, giving us a volume of 36 pi fifths. All right, and that is an example of finding a volume of a shape that's changing and then rotating around the x-axis.